When manufacturer instructions or grounding hole locations for solar photovoltaic module frames are inadequate, alternative grounding methods are permissible in various jurisdictions. In the United States, the National Electrical Code, or NEC, allows for alternative grounding methods. These methods may include grounding clips or clamps, conductive bonding devices, and bonding jumpers. In Canada, the Canadian Electrical Code, or SEC, mandates that solar photovoltaic module frames must be grounded in accordance with the manufacturer's instructions. However, similar to the United States, if the manufacturer's instructions or the grounding hole location is not adequate, alternative grounding methods may be used. These methods also include grounding clips or clamps, conductive bonding devices, and bonding jumpers. Within the European Union, the European Standard for Photovoltaic Modules, IEC 62548.2018, specifies that solar photovoltaic module frames must be grounded in accordance with the manufacturer's instructions. Likewise, if those instructions or the grounding hole location prove inadequate, alternative grounding methods are acceptable, including grounding clips or clamps, conductive bonding devices, and bonding jumpers. In Australia, the Australian Standard for Photovoltaic Installations, /NZS 5033.2023, states that solar photovoltaic module frames must be grounded in accordance with the manufacturer's instructions. Again, alternative grounding methods are allowed when the manufacturer's instructions or the grounding hole location is inadequate. These methods include grounding clips or clamps, conductive bonding devices, and bonding jumpers. Many other jurisdictions worldwide have similar requirements for grounding solar photovoltaic module frames. However, it is crucial to recognize that the specific alternative grounding methods permitted can differ based on local regulations. Consulting with local authorities is always imperative to ascertain the precise requirements within a specific jurisdiction. Grounding clips or clamps provide a mechanical connection to the module frame, ensuring a reliable path to ground. These clips are designed to bite into the metal frame, creating a secure electrical bond. Conductive bonding devices, often using specialized adhesives or compounds, establish an electrically conductive pathway between the module frame and the grounding system. These devices enhance conductivity, especially when dealing with dissimilar metals or surfaces that might corrode over time. Bonding jumpers are short links of conductive wire used to connect different parts of the module frame or to connect the frame to the main grounding system. These jumpers provide a redundant grounding path, ensuring that all parts of the frame are at the same electrical potential. When choosing an alternative grounding method, several factors should be considered. Firstly, the compatibility of the grounding hardware with the module frame material is crucial. Dissimilar metals can lead to galvanic corrosion, which can weaken the grounding connection over time. Secondly, the environmental conditions at the installation site must be taken into account. In areas with high humidity or corrosive atmospheres, corrosion-resistant materials should be used to ensure a long-lasting grounding connection. Thirdly, the ease of installation and maintenance of the grounding method is important. Grounding solutions that are easy to install and inspect can save time and money in the long run. Fourthly, the grounding method should comply with all applicable codes and standards. The NEC, SEC, IC, and the /NZS 5033.2023 provide detailed requirements for grounding solar photovoltaic systems, and it is important to follow these requirements to ensure safety and compliance. The National Electrical Code, or NEC, Article 690 covers solar photovoltaic systems. It provides requirements for grounding, wiring methods, overcurrent protection, and disconnecting means. Section 690.41 of the NEC addresses grounding requirements for solar photovoltaic systems. It specifies that exposed non-current carrying metal parts of solar photovoltaic equipment must be grounded, regardless of voltage. This includes module frames, racking systems, and equipment enclosures. The Canadian Electrical Code, or SEC, Section 64 addresses renewable energy systems, including solar photovoltaic systems. It provides requirements for grounding, wiring methods, overcurrent protection, and disconnecting means. Rule 64.210 of the CEC covers grounding requirements for solar photovoltaic systems. It specifies that all exposed non-current carrying metal parts of solar photovoltaic equipment must be bonded to ground. The IEC 62548.2018 standard provides requirements for the design, testing, and installation of solar photovoltaic modules. It includes requirements for grounding, wiring methods, and safety. Section 6.5 of IEC 62548.2018 addresses grounding requirements for solar photovoltaic modules. It specifies that module frames must be grounded in accordance with the manufacturer's instructions. The S/NZS 5033.2023 standard provides requirements for the installation of solar photovoltaic systems in Australia and New Zealand. It includes requirements for grounding, wiring methods, overcurrent protection, and disconnecting means. Section 4.5 of S/NZS 5033.2023 addresses grounding requirements for solar photovoltaic systems. It specifies that all exposed non-current carrying metal parts of solar photovoltaic equipment must be bonded to ground. In addition to these codes and standards, local regulations may also impose specific requirements for grounding solar photovoltaic systems. It is important to consult with local authorities to determine the applicable requirements in a specific jurisdiction. When selecting grounding hardware, it is important to choose products that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, Oracle, or Intertek, or ETL. These listings provide assurance that the products have been tested and meet applicable safety standards. Grounding clips and clamps are available in a variety of materials, including stainless steel, aluminum, and copper. Stainless steel is a good choice for corrosion resistance, while aluminum is lightweight and conductive. Copper is highly conductive, but may be more susceptible to corrosion in some environments. Conductive bonding devices are available in a variety of forms, including tapes, pastes, and liquids. These devices typically contain conductive particles such as silver or copper that provide an electrically conductive pathway. Bonding jumpers are typically made of copper wire and are available in a variety of sizes. The size of the bonding jumper should be appropriate for the fault current that it is expected to carry. The NEC specifies minimum wire sizes for grounding conductors based on the size of the overcurrent protection device protecting the circuit. When installing grounding hardware, it is important to follow the manufacturer's instructions carefully. This will ensure that the grounding connection is secure and reliable. Grounding clips and clamps should be installed on clean, unpainted surfaces to ensure good electrical contact. Conductive bonding devices should be applied according to the manufacturer's instructions, ensuring that the surfaces are properly prepared. Bonding jumpers should be securely connected to the module frame and the grounding system using appropriate connectors. After the grounding system is installed, it should be inspected and tested to ensure that it is functioning properly. A ground resistance tester can be used to measure the resistance between the module frame and the grounding electrode. The resistance should be low, typically less than 1 ohm, to ensure that the grounding system is effective. Regular maintenance of the grounding system is important to ensure that it continues to function properly over time. This includes inspecting the grounding connections for corrosion and tightness and replacing any damaged or worn hardware. In some cases, it may be necessary to retorque grounding connections periodically to ensure that they remain secure. Proper grounding of solar photovoltaic module frames is essential for safety and performance. Grounding protects against electrical shock hazards by providing a low impedance path for fault current to flow back to the source. This causes the overcurrent protection device, such as a circuit breaker or fuse, to trip, interrupting the flow of current and preventing a potential shock. Grounding also helps to reduce the risk of fire by preventing the buildup of static electricity. Static electricity can ignite flammable materials such as dry vegetation or building materials. Grounding also helps to protect solar photovoltaic equipment from damage caused by lightning strikes. Lightning can induce high voltages and currents in solar photovoltaic systems, which can damage or destroy sensitive electronic components. By providing a path for lightning current to flow to ground, the grounding system can help to protect the equipment. In addition to safety, proper grounding can also improve the performance of solar photovoltaic systems. Grounding helps to reduce electrical noise, which can interfere with the operation of electronic equipment. It can also help to improve the efficiency of the solar photovoltaic modules by reducing voltage losses. Overall, proper grounding of solar photovoltaic module frames is essential for safety, performance, and reliability. By following the requirements of applicable codes and standards and consulting with local authorities, you can ensure that your solar photovoltaic system is properly grounded and protected. Understanding the specifics of each jurisdiction is paramount. For instance, what is acceptable in Arizona under the NEC might have subtle but crucial variations compared to installations governed by the CEC in Canada or under the stringent regulations of the IEC standards within the European Union. The Australian standard /NCS 5033.2023 introduces further nuances tailored to their specific environmental and safety considerations. It's not a one-size-fits-all scenario. Local amendments and interpretations can significantly alter the application of these standards. Engage with local electrical inspectors and authorities during the design and planning phases. Their insights are invaluable in ensuring compliance and avoiding costly rework. Furthermore, consider the long-term maintenance of the grounding system. Environmental factors such as salt spray in coastal areas or extreme temperature fluctuations in desert climates can accelerate corrosion and degradation of grounding components. Regular inspections and preventative maintenance are essential for maintaining the integrity of the grounding system over the lifespan of the solar photovoltaic installation. In planning a solar photovoltaic system, always factor in the costs associated with proper grounding. While it might be tempting to cut corners to save money, inadequate grounding can lead to serious safety hazards, equipment damage, and potential code violations. Invest in high-quality grounding hardware and ensure that the installation is performed by qualified professionals. The choice of grounding hardware is not arbitrary. Different materials and designs offer varying levels of performance and suitability for different applications. Stainless steel grounding clips offer excellent corrosion resistance in harsh environments, while copper bonding jumpers provide superior conductivity. Consider the specific requirements of your project and choose the hardware that best meets those needs. Proper documentation of the grounding system is essential for future maintenance and troubleshooting. Maintain detailed records of the grounding hardware used, the installation procedures followed, and the test results obtained. This documentation will be invaluable for identifying and resolving any grounding issues that may arise over time. Grounding is not merely an afterthought, it is an integral part of the solar photovoltaic system design. By considering grounding requirements from the outset, you can ensure that the system is safe, reliable, and compliant with all applicable regulations. Remember that continuous education and training are crucial for staying up to date with the latest grounding techniques and code requirements. Attend industry workshops, read technical articles, and participate in online forums to expand your knowledge and skills. The field of solar photovoltaic technology is constantly evolving, and it is important to stay informed about the latest developments. In addition to the specific grounding methods discussed, there are other techniques that can be used to improve the effectiveness of the grounding system. These include using ground enhancement materials to improve the conductivity of the soil, installing ground rods in a grid pattern to reduce ground impedance, and using surge protection devices to protect against lightning strikes. Consider incorporating these techniques into your solar photovoltaic system design to further enhance its safety and performance. When dealing with large-scale solar photovoltaic installations, it is important to consider the potential for ground faults. A ground fault occurs when an unintentional electrical connection is made between a current-carrying conductor and ground. Ground faults can create hazardous conditions and can damage equipment. Implement ground fault detection and interruption systems to quickly identify and isolate ground faults. These systems can help to prevent electrical shock hazards and equipment damage. In conclusion, grounding of solar photovoltaic module frames is a critical aspect of solar photovoltaic system design and installation. By understanding the requirements of applicable codes and standards, consulting with local authorities, and using high-quality grounding hardware, you can ensure that your solar photovoltaic system is properly grounded and protected. Remember to prioritize safety, performance, and reliability, and always stay informed about the latest grounding techniques and best practices. This ensures not just code compliance but also the longevity and safety of the solar installation, protecting both the investment and the people who interact with it. It is also good to engage with the wider community of solar photovoltaic installers and engineers. Sharing experiences, challenges, and solutions can contribute to the collective knowledge and improvement of grounding practices. Forums, industry events, and online groups offer valuable opportunities for learning and collaboration. Always remember that electrical safety is paramount. When working with electrical systems, it is important to follow all safety precautions and to use appropriate personal protective equipment, or PPE. If you are not qualified to work on electrical systems, hire a licensed electrician to perform the work. Understanding the specific requirements for grounding solar photovoltaic module frames in various jurisdictions is crucial for ensuring safety and compliance. When the manufacturer's instructions or the grounding hole location are inadequate, alternative grounding methods may be used. These methods include grounding clips or clamps, conductive bonding devices, and bonding jumpers. The National Electrical Code, or NEC, allows for alternative grounding methods if the manufacturer's instructions or the grounding hole location is not adequate. The Canadian Electrical Code, or SEC, requires solar photovoltaic module frames to be grounded in accordance with the manufacturer's instructions. If the manufacturer's instructions or the grounding hole location is not adequate, alternative grounding methods may be used. The European Standard for Photovoltaic Modules, IEC 62548.2018, requires solar photovoltaic module frames to be grounded in accordance with the manufacturer's instructions. If the manufacturer's instructions or the grounding hole location is not adequate, alternative grounding methods may be used. The Australian Standard for Photovoltaic Installations, as/NCS 5033.2023, requires solar photovoltaic module frames to be grounded in accordance with the manufacturer's instructions. If the manufacturer's instructions or the grounding hole location is not adequate, alternative grounding methods may be used. Other jurisdictions may have similar requirements for grounding solar photovoltaic module frames. However, the specific alternative grounding methods allowed may vary depending on local regulations. It is always important to consult with local authorities to determine the requirements in a specific jurisdiction.